Hello, hi everybody, welcome back. The last lecture we have discussed how to draw a 3D drawing or how to convert a 2D drawing into 3D drawing. It is nothing but an orthographic projection into an isometric projection. The 2D projection we'll call it as orthographic projection and 3D projection we'll call it as isometric projection. And in orthographic projection, know that the angle between the sides are 90 degree and we'll be using the axis x-axis and y-axis as well as x-axis or z-axis where the angle between the axes are 90 degree. Okay. Now when we convert this orthographic projection into isometric projection, what we have done is we will change this angle from 90 degree to 120 degree, and these three are x, y and z are the isometric axis. There we will mark the length of the solid on this axis, x-axis, breadth on y-axis and height on z-axis. So we will get all the three dimensions on a 2D plane. But the problem with this, when we convert the orthographic projection to isometric projection, all the measurements get reduced by 0.82 times. That is, the ratio of isometric length to actual length is 0.82, which is called as isometric scale. So all these we have discussed in the last lecture. And when in order to draw the isometric projection of a square box, we will mark the length on x-axis, y-axis, then height on the z-axis, join all the lines, and you can see that all the lines are parallel to the axis, so we can very easily draw the isometric projection if you know the orthographic projection. And in the case of a square, you can see that all the sides are orthogonal, that is 90 degree. But when you come to the case of another solid or another polygon triangle, here you can see that the sides are not orthogonal or 90 degree. It is having some inclination. So the most important, very important point that you should keep in mind while doing isometric projection is only the horizontal or vertical distances should be transferred to the isometric axis. You are permitted to transfer only horizontal or vertical distances directly to the isometric axis. Okay. So in this case, you can see that you can directly transfer the point A and B to the isometric axis because it lies in a vertical line. So I can mark that distance or that point directly. A here, take the distance of B from the point A, I can mark it here, and never find the point C by taking the distance of B from C and A from C, cut an arc and find the point C. That is wrong. You can find out only this distance by taking the vertical and horizontal measurements. So for that, what we will be doing normally is we will set the point C in a vertical line. Now we can see that this distance of C is in a vertical line, or this becomes a vertical measurement. So I am enclosing this triangle ABC inside a box. Okay, so I am enclosing this triangle inside a box. I can name it as 1, 2, 3 and 4. Now you can see that all the points are A, B and C are lying in a horizontal line or in a vertical line. So I can directly transfer the distances of the points to the isometric axis. So I can see that the point C is lying in a vertical line 3, 4. So first of all, instead of marking the points A and B for this type of polygon, what we'll do is we will draw the isometric projection of 1, 2, 3, 4 first. So 1, take the distance of 2 from the point 1, take the distance of 4, mark it here, then from 2 you can mark a distance of 3, or draw a line parallel to 1, 2, through 4, draw a line parallel to 1, 4, 2, 3, get the point line 2, 3. Now the point A is along with 1, so I can directly mark the point 1. The point 2 is along with B, so I can mark it here, B. How will you mark the point C? It is at a distance of 4C along the line 3, 4. So either you take the distance of 4C or 3Z. Here in this case, both distances are same, and there is a vertical measurement. So I can mark that point here, C. Now I join this where straight lines. So I got the isometric projection of this particular triangle. Thank you.